All right, we're going to get started. Actually, it's going to be Brian and Diogenes that are going to do this. There's actually going to be a demo as part of this. And what I'd like to ask is during the demo, if there's a key thing that you want to spend a little bit of time on, you want to understand a little better, absolutely ask the question when the demo's happening, because it's a little tough at the end of it to kind of go backwards, right? We want everyone to get a lot of value out of it. So please, during the demo, if there's a key piece that you'd like to understand a little better, you'd like to see a little deeper, absolutely stop us and ask the question. So with that, I'm going to leave it to Brian and Diogenes.
Great. Thank you very much. First off, thank you all for sticking around, staying afterwards. There's three really hard things to do in the technology industry. One of them, obviously, is naming anything. You all know that. The second one is trying to do really high-density wireless. And the third one is trying to figure out the heating in a room. We're not going to solve any of those problems today.
The fourth one?
Yeah.
The fourth one is live demos.
That's right. So what we thought we would do, we've got about 50 minutes. We're the same guys that you saw this morning. We're just a little bit taller. We're not going to sit down. We're going to stand up this time. And what we thought we would talk about for the next 45, 50 minutes is, we've been talking a lot about this transformation, moving to digital, all those types of things. And what we're going to do is do a couple of things. We're going to talk a little bit about how a technology called containers. How many of you have some background with containers, have some interest in containers? All right, cool, lots of hands. We're going to talk a little bit about this collaborative thing called DevOps. How many of you interact with any of your colleagues at all? Okay, you're all perfectly humanly capable of doing DevOps. And what we thought we would do, instead of showing you the same slides over and over again that talk about infrastructure and applications and so forth, you've seen those enough, we thought we would show you a live demonstration, which is, like you said, sort of the fourth thing that, there's no net, we're going to go live, ask questions as we go along, okay? And hopefully all's good with the wireless. So you've seen this slide, or you've seen a variation of this slide, and the thing about this is, we have this sort of interesting challenge right now. Whether or not you are in an industry that there is somebody coming out of Silicon Valley, coming out of wherever that's disrupting you, or you're just looking at the pace of change that's going on because now maybe your customer interface is a mobile phone when it used to be a bank teller or an ATM machine, or you are a retailer and again you're having to compete with some people at a very large scale. And what's going on is, and the reason that we're hearing about this container technology is you sort of go, what does container technology do for me? Because quite honestly, the Linux version of this, which is what we're going to talk about, has been around for 10 years, right? It used to be called C groups and namespaces and so forth. So it's been around for 10 years, so why is it such a big deal? And the idea of sort of virtualizing at an application level or at a process level has been around in computing for 25, 30 years, right? We've had them as Solaris zones in Unix, and we had LPARs on the mainframe and an AIX and other things like that. But ultimately what's sort of happened is the industry's changed. The customer expectation has changed. Anybody who's got kids knows that you can sit around at a table like this having dinner and their attention span is all of about 15 seconds. And so what ends up happening is you look at all these things that people are trying to change. They're trying to respond to the market faster. They're trying to, take back the idea of developing their own software. So they're moving away from a lot of packaged software. They're coming back and they're saying, if the market's changing, I probably understand the market better than some company that's trying to sort of build me the 80-20 rule. And then we're seeing more and more the ability for people to say, I have an idea, I want to go execute that, and I prefer not to wait for our next long budget cycle. So it'd be nice if I could take advantage of whatever resources are freely available to me, whether those are in my own data center, on premises, or they're somewhere in a public cloud somewhere that you can go take advantage of. And even if you're doing nothing more than just experimentation to figure out if that lighthouse idea is worth spending another dollar on, or a dollar loony, or another whatever, right? So containers sort of come along, and they're this interesting technology for a couple of reasons. One, in the past, we would come along, the vendors would walk out here and we'd go, hey, I've got something brand new, and it's going to save you a whole bunch of money. And if you were the people that were sort of the focus of that thing, you were, Deduplication for storage, you went, cool, we're going to save 25%. I don't know if that affects anybody else in the company. We're going to do something else. It might affect us. I don't know if it affects anybody else in the company. Containers are this really powerful technology that have characteristics that are valuable to developers. They allow developers to say, hey, if we're going to start building applications that are a little smaller in scale, or we're going to build them as services, I'd like to be able to, think in terms of these smaller things. I'd like to be able to package them such that if I'm actually making changes more frequently than I was, I'm making changes more than every 6 months or every 12 months or 18 months, maybe I'm making them once a day, multiple times a day, I want to be able to use technology that's going to help me get it through that pipeline consistently, right? So it's, in a lot of cases, people talk about containers being the new tarball, the new sort of packaging format. And if you're on the operations side of things, you go, okay, I've lived through virtualization. I sort of get this idea that the world isn't sort of a physical box and a physical cable anymore. There's some things I'm going to have to think about. But I now have this technology, and I have a bunch of platform technology that's out there that lets me say, cool, if they're going to give it to me faster, developers are going to give it to me faster, and those applications are going to be a little bit different, I can take advantage of these new platform technologies that have integrated automation, integrated scaling, integrated security. So it's really one of the first times that we're seeing kind of a really core technology be impactful to both the dev side and the ops side, right? Now, it doesn't come without its challenges and so forth, but we're seeing this happen, and it aligns really, really well with this idea that I want to go faster. It's a technology that, at a most simple level, runs faster than we saw with virtual machines. I don't have to wait for 3, 5, 8 minutes for the Windows operating system to come up. It just takes advantage of what there in Linux. Inherently takes advantage of what there from a security perspective in Linux. But what we thought we would do, instead of sort of talking about this a whole lot, is we thought we would show you. How many of you have ever seen just containers working in production, containers working live? Folks? How many folks have seen sort of Red Hat's version of this, the platform that we deliver called OpenShift, working? Cool. We're going to show you that, okay? And as we go along, ask any questions you want. What we're going to try and do, Diogenes is going to sort of walk you through deploying some applications, showing some of the interaction with it, and then we're going to kind of, try and relate this back to why it benefits your company at all. So, fire away.
Thank you. Okay, boring slides, boring slides. Okay, let me talk about this thing. This is actually the interesting thing that I want. Yeah, like, how many slides have you seen today? We have more. And okay, now if you know the story, pretend that you don't right now. Okay, so how many of you know why this is called WD-40? You should have pretended that you don't. Okay, good. So we have one guy there that you know. So this is a very interesting story behind this thing, right? First of all, we all do use this for everything. It's like one of the 2 main ingredients of every single engineering project. The second is duct tape, right? So if it moves and it shouldn't, duct tape. If it should move and it's not, WD-40. That's pretty much how we do life, right? But there's a nice story around this, is that this is called WD-40 for one very interesting reason. It's called, it means water displacement. That's what the WD is for. And the 40 is the formula number 40, right? So that's what it means. So it's a very interesting name for a product. So yeah, we tried 39 times, we failed, but the 4th time we got it, 40th time we got it right, and that's the way we're going to name the product, right? So someone tried 39 times and failed the 39 times. Let's have this in mind. And how long does it take for you to realize that you have failed in your project or on your idea, right? Does it take 1 month, 2 months, a week? So if you are very fast, it's going to take between a week and a month. So if it takes 1 month, it's going to take at least, let's say, this guy would have taken 2-3 years to realize that until he had a good product. The time that he had in hand to develop this was much less than that. It was the initial purpose of this is to be used as a coating in jet fuel tanks. So that's why it is. So let's have this in mind, that this inventor, he was able to innovate because he was able to try and fail, right? And he could clearly see that he was able to try and fail because he actually failed 39 times, right? If he was given 1 chance, two chances, or let's say 10 chances, he likely wouldn't have a product, right? And that's why I strongly believe that the environments that we have in IT, they should follow the same rules that regular product design follows. They should encourage experimentation. Right? But it doesn't happen. So if your developer wants a virtual machine to play, to try things, he's punished because it's going to take him like a week, sometimes a month, to get this virtual machine. So you are punishing the experimentation. And innovation does not happen in environments that punish experimentation. What was that? Unless we're all geniuses, unless you can all get it right for the first time. I could not get it right for the first time, right? We just had to change this presentation for this context. So like if we went up doing the presentation which we thought it would be the one, it wouldn't be the best presentation for you. So like we didn't get it right the first time. So you have to have an environment that encourages experimentation, right? And in order to have this environment, there are a few pieces that make it. So I'm going to jump to the demo, if that's okay.
Show it to me first and we'll come back and tell what they saw.
Awesome, awesome. So this is an environment that encourages experimentation. Very good. So let's see, this is my OpenShift UI. So for those of you that have never seen OpenShift, this is an OpenShift UI, right? This is running on the cloud. So this OpenShift that I have here running is running on AWS. It could run anywhere, pretty much, right? So everything that happens on OpenShift happens inside the project, right? So in this project I have it looks like three, but I have 2 containers deployed. Let me just group this here because they are part of the same application. Okay, so I have this containers deployed, and one is a EAP application server and another is a database, right? And very good thing here is that this project that I have is quota bound, right? So everything that happens in OpenShift happens in a project, and I have a quota. So developers, they are assigned a quota to play in a project, or QE environments are assigned a quota, or production environments are assigned a quota. You know, what is a quota? It's a set of storage capability, storage, access, memory, and CPU, right? So for this project that I have here, let me see where I see this. This project, my quota, I can come to the monitor and see how much I have. But for this project right here, I know that my quota is I'm almost there, right? I can have 4 cores running, and I'm almost at capacity for my quota. I have 4 cores. So that's let's go a little bit on the slides and then talk a little bit more about this.
So before we turn to that, so what are we seeing here? I've got self-service access to a bunch of available resources that run anywhere. So from a developer perspective, I don't need to contact a bunch of admins to go make things work for me. I have self-service access to that. We have a Java EE application.
Yeah.
We've got JBoss EAP on here. So a lot of times we talk about containers, we talk about these cloud-native applications. They run perfectly well on this platform. It runs, in fact, really, really well. But this is a platform that also allows you to bring existing applications onto the platform. And then the last thing is, from a ops perspective, you have the control, right? Everyone wants to talk about shadow IT and how IT is losing control. We give you control to be able to say, hey, I've got to manage budgets. I've got to be able to manage these shared storage pools and shared network pools and shared compute pools. I want to make sure that I have a visibility and control. We give you both of those. Yeah. So we make it simple for developers, and we keep control for those operations folks.
Very good. Here you have a list of the things that you can deploy, let's say by default on the platform, but any operator, any, let's say, cluster administrator will be able to say, you can use PHP version 5.6, but you cannot use version 5.5. Or you can use this Java version EAP 7, but you cannot use EAP 6.4. And this is the catalog that I, as a developer, would see to create and build my apps. Now, talking about a developer, there's a very important aspect, right? Because this is, let's call it a production environment, and this is running in AWS, but if I'm still developing on my machine and I'm testing on AWS, that feels a little bit weird, right? And I want to show you I think one of the best pieces of technology that we've created lately. And it's a magical tool called OC Cluster Up, right? So what is OC Cluster Up? OC Cluster Up, OC, it's the command line for OpenShift. So OC is like, as in OpenShift command line, right? Minus H, it shows me a list of options I can have. And sorry for showing a black screen, but this is a very awesome demo. So imagine that I want to have an environment in my local desktop as close as possible to production. And this is what I'm going to do with OC cluster up, right? I'm going to actually start a OpenShift and this machine here. Start a complete OpenShift cluster on this machine here. I'm going to enable metrics on this cluster because I find it cool. And that's what I'm going to do, right? So how many times do we have to develop in one environment and test, and the developer has to test in one environment, and when things go to production, it's a totally different thing, right? So as I was telling in the panel, like you create a WAR file, and then you throw the WAR file to someone, and that someone luckily catches the WAR file and a set of instructions and tries to put that into production, right? But with tools like this, we enable a developer to have OpenShift running on their own laptops. So they can, the same UI that I showed you earlier on the cloud, now I can have running on my laptop. So let's just access this. This is an internal IP. And I'm going to log in as incognito, so I just don't have any previous session. And there you go. Developer.
So with one command, you have Kubernetes, which is the underlying technology. You've got OpenShift, which is the enterprise add-ons, and you've got the ability to natively interact with Docker right there on your laptop.
It's a very good point that you brought. So the only thing that was required for me in this laptop was a Docker engine, right? So Docker engine is available in any Linux box. It's using in this Mac, it's using the native virtualization called X-High for Mac. But we have a very other awesome product called CDK, which is available in our developers program. So this website here, I strongly recommend every single one of you to join, which is our developer program. So where on this website is where we make available for you at no extra cost things like RHEL for development purpose. So through the developer program Red Hat, it was the first time we've ever gave Red Hat Enterprise Linux at no cost at all for developers. And in this you'll find not only blogs, but you'll find also the developer kit. So you can come here to OpenShift. Should be here. OpenShift Enterprise by Red Hat. And you can actually download a get started, and you can actually download a copy of the container development kit. It takes you to log in. And then you're going to have the enterprise version of OpenShift running on your laptop. So there are multiple ways you can have OpenShift running on your laptop. Again, strongly recommend that you join this, right?
Yeah, the powerful thing to think about with this is you will be absolutely smarter than your Red Hat sales rep when he comes the next time to talk to you about Red Hat OpenShift. You will have been playing with this on your laptop locally, and you can go, oh, I got questions this time. I hope you have answers.
Very good. I have an app here running here from a previous world. Let me just close this. Okay, so I have a project. Like, let me deploy a project. I show starting up the whole OpenShift cluster from scratch. Now I'm going to show deploying a project, deploying something, right? Because that's what we want to do, right? Now, does anyone here have a Docker image on Docker Hub that they are brave enough to share? Okay, that's okay. That's understandable. But OpenShift can deploy any Docker image at all, right? We had some very interesting verifications on the Docker image. I'm just going to do an example, and then I'll let Brian talk about what's going on here. I have a image on Docker Hub called OC, which is just the OC command line, right? So I just verify, and then so this image, Brian, is telling me that it's running as root. What do you think about running things as root in a production environment, like arbitrary internet code as root?
That would be bad?
That would be bad, right?
Yeah.
So we do some verifications, but watch out. Most of the Docker images out there, they actually require root to run. And I kind of don't trust the internet, so if you do trust the internet, it's okay. But I have, let's say, some particularities about just using any arbitrary internet code available there, right?
So somebody asked some questions about security this morning. A lot of this sort of security technology is built into the platform. It basically says, yes, you can go do dumb things, you can go do insecure things. We're going to try and prevent you from doing that, right?
Yeah.
So this is this sort of first layer that's built in. Are you going to give me root access to the file system?
Now, there are situations where root access to a container is a good thing, right? And we can enable root access for very specific purposes in OpenShift, and we do this, right? So when we talked about CloudForms and the way CloudForms inspects what's going on in containers in the images, that thing doing the inspection is a super privileged container, So it's a container that's running under a special security context that you as the customer administrator has allowed that security context to happen, and that one container has access to the other containers and the other images, so it could inspect, it could verify if inside those images or those containers there is any RPM or any library that with a vulnerability that was being already made public. Very good, so let's go to the app. I'm talking too much and no app deployed so far, right? I'm just going to do a Node.js app because it's faster than Java. Don't let anyone know that I told this, but to play it is faster than Java. So I'm going to do this, and we in OpenShift, we want to automate every single possible step between code to production, right? Now, one thing happens here. So I need to create a route for my application. Like, how many of you need to open a ticket to have a DNS addressable route for your application? Like, okay, is that ticket answered in like 1 hour?
And he's given a look like, oh my God, I can't think of a worse thing than having to open that ticket. Like, it's painful.
Well, so, no, just to get the ticket, okay. So as we want to automate, OpenShift takes care of a lot of things. So it's important. Let's be honest. OpenShift, when you install it, it's all about unplugging everything that you have and you plug it into OpenShift. Since you're giving OpenShift a lot of control, it has to know about lots of things. So one of the things we do, it's basic DNS routing, right? It has an internal DNS router that we use for service discovery, but you can also assign a wildcard DNS to the OpenShift hosts, and your corporate DNS will be able to route to that wildcard whenever it's needed. So that allows the platform to create any routes, as many routes as needed. So I'm going to do the defaults here and just let things happen, right? Now, let me do something crazy here. What's happening here, Brian? 100 millicores for an app? Like, could I do this with virtualization, assign 10% of a core in virtualized environments?
No. So this is the powerful thing about containerization in OpenShift. So one of the first things that people always ask us is like, does containers mean I have to get rid of virtual machines, or do I compare one versus the other? The way to think about it is, yes, you can run applications in either one of them. Containers lets you get really, really granular, lets you get really dense in terms of packing them down to sort of millicores. We're not talking about sort of cores and multiple cores. We're talking about, if I've got a small application, I just want to use what I need for the application.
And if you were doing immutable deployments with virtualization, it's a valid use case. You can do immutable deployments with virtualization. You have your application server, you have a virtual image, and then you spin up a new image, right? So anytime you need a new instance of that application, you're going to spin up a new image. That's a valid use case for auto-scaling. But what if your application what if one core it's big enough for your application? Then you're just throwing away compute power, right? I'm going to create this and see what happens, right? So let's have this in mind. Everything is happening in this machine. And yes, I'm using internet. So let's hope it goes. So I have created the project. And if I go to monitor, I see that something is running here. So like, I have a build running. Let me just make it a little bit bigger. And I have a build running. So OpenShift, as it tries to automate, it knows how to do things. So we are able to do node builds, or essentially NPM installs, right? That means that we can identify that we need to do an NPM install for application, download all the NPM dependencies, and we're going this. What happening here is now that we're pushing the image, right? So it's doing a lot of things. So and that was very quick because I used a certain Git repo. So we went to GitHub, clone. Let me show a very good slide on that. For that we have a good slide.
Now, before he jumps into that, there was two things we didn't actually show, just from a timing perspective, that are really, really important, really sort of powerful. I had a question yesterday. I was doing a similar show down in North Carolina, and somebody said, "This is cool, except you keep saying that thing where you go, we're going to push it into production." And he did that thing where he goes, "I don't think you mean what you keep saying you mean." And the reality is, when we say push things into production, replace the word production, sort of find, replace. That could be push into QA, push into sandbox, push into staging, right? And there's a couple of things that are really powerful that are built into OpenShift that are going to help us do that. Right? One of them is, and we didn't end up using any tags on this, there's a tagging mechanism that the system will pick up if you want to do multiple tenants. So if I want to assign you to, say, I don't know, marketing or finance or something, we can just pick up all the things that he's working on and assign him to finance resources, right? You don't have to think about that. They just kind of get picked up by default. The other thing is, those images that you saw that were in the catalog, we'll have a lot of folks who will say, hey, look, what we run in QA, we may have a standard for that that's sort of always bleeding edge, middleware, bleeding edge, whatever. But when we get into production, we do something else. You know, we talk about immutable. Do we want to make sure that the same thing? You can also build things like environmental variables and various things that you want to pre-package in some of those things that come out of the service catalog. So there are some powerful ways to build into the system sort of, you know, human-proof, making sure that the right code, the right builds, the right tags go into where you want them to go, and developers just go write code.
Yeah. So this is what happened. I think it's already completed, right? So I had some code residing somewhere, and this is like for demo purposes. We just put it on GitHub, but it can pretty much connect to any SVN. And it can do also what we call binary build, so you don't need to send us the source code. If you already have a continuous integration in place that packages your application, you can send us the WAR file, and we will create that image. Is there a question there?
Yeah, when do you recommend source image versus the binary deployment?
Question, when do I recommend source to image versus a binary deployment? I think it will be it's a lot tied into your politics as well. So
why don't we explain to folks what source to image is to begin with? So it's a great question. So one of the biggest things that we get from people is they go, what are my options in terms of pushing code onto the platform? Because maybe a couple of years ago, if you had been using Heroku or Google App Engine or something that was called a PaaS, the idea was always like, let developers write code, don't think about anything else, just throw it at the platform and it'll figure it out. And that's fantastic. If you simply want to give the system sort of code, give it a repository, it works great. And then a couple of years ago, the folks at Docker figured out this really simple way to take 10-year-old container technology C groups and make it stupid easy. I mean, really easy. Docker run, boom. And so we saw a whole lot of developers who came along and said, I like this idea of packaging stuff locally on my laptop, and I'd like to just push that into it. So you had this semi-code, semi-Docker file, and then others that would come out of a CI/CD pipeline that would give us a binary. And we sort of said, well, instead of being really opinionated about that, about how you're going to give us essentially whatever you want to run, we're going to support all of them. And the one caveat that we made about that, because we said within the system it should run containers, right? There had to be some mechanism that said if you give us something that's not a container, so a binary or sort of source code, we want to be able to package that the right way. And that's what source to image is. It's an open technology that we bundle as a part of OpenShift. And to answer your question, I think it really depends on what you're comfortable with. We have customers who say
they've invested already in CI systems and they want to leverage
that's right. I've got Jenkins, I've got whatever, Bamboo, TeamCity running elsewhere. Cool. We can hook directly into that. Yeah. We've got other customers who are now saying, my build system doesn't run all the time. We're not Etsy. We don't deploy 100 times a day, but I have these spikes. Could I run that on top of the platform? Yeah. You're giving me a platform that's scalable, and it takes applications like a build pipeline. Yeah. Could I build that into there? Can you guys do some interesting stuff? And we've actually made it such that you can run your Jenkins, your CI/CD pipelines native on the platform and take advantage of its scalability. Yeah. So the answer is it kind of is up to you. The good news we like to think about it is we're not opinionated about what you want to do. Okay.
Sure. And C-source is not source code. That's anything that will end up generating an image. So what happened in the background while I was explaining this is that OpenShift went to Git, cloned that source repo, right? It figured out, this is a node. So I just need to do an npm install on that, and then combine that source code with a base image, which here we call the builder image. And this is important. In Red Hat, we deliver a set of base images that we maintain the life cycle of them. So if there is a vulnerability in any of the components of the base image, we fix that vulnerability, so you're always using code that's updated, right? I'm sure it's finished by now. Let's make sure I have the correct thing, because I end up having multiple. right. Good. So my Node.js application is running. It's very complex Node.js application. Prepare yourselves. It's the most. This is the Node.js application. This is all of it, right? But it's a very, very complex Node.js application. Let me just open again, just to prove that I'm not lying this time. Okay, open here. Good. So this is my Node.js application. Very complex. And I think I'm going to want to scale this application up, right? So let me see how hard it is to scale an application up. You have any ideas how I could scale this application up? Press the arrow. Let's try. Okay. 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 Now it's gray and now it's blue. Okay, let me try it again. Okay. Okay. Yeah, I like this thing. This thing is nice, right? So now I'm going to have 12 instances of my application, and they are running on this machine. And if I have 12 instances, like how do I know where traffic goes, right? So we actually embed a load balancer. So OpenShift comes with a load balancer, which we call the router, but it's essentially a load balancer that will load balance the traffic between the instances, right? And I'm sure you've heard of A/B routing, right? You've heard of A/B routing, like Brian wanted to just give a little explanation of what A/B routing is.
Yeah, so one of the things that we get from folks all the time is they go, hey, applications change, we want to do upgrades, we want to do maintenance on them. How do I go about doing that without sort of taking the thing down? We now live in this 24/7 world. I really don't have outage windows anymore. Saturday and Sunday mornings, I prefer not to be working. The system, in essence, has things built in that say I can do blue-green deployments, so meaning I can leave what's out there, I can deploy the net new, I can begin to route part of the traffic to that net new, make sure it works, make sure everything's cool, it didn't blow anything up, and then move everything over to that one. And then we can do A/B type of routing, which is a little more granular in terms of I'm trying to figure out, did that new change that I have, I want to route 50% of the traffic, I want to route some known percentage of the traffic to that. And over time, what you're going to see from us is not just can I do routing and updates without taking things down, but you'll begin to see us doing some things that incorporate some of the business logic that say, hey, if I'm trying to roll out some sort of new launch for a product, or I'm trying to do some things that have a business angle, I want to be able to tie in that A/B logic as well. So again, the thought about this is simple upgrades, non-disruptive upgrades. I can make sure that what I have is going to work. If it doesn't work, I can quickly, immediately do rollbacks. The system still has a copy of the previous version. All that built into the system. I don't have to think about all these things that can move, and hopefully don't have to do them on Saturday night at 2 in the morning.
Yeah, awesome. So, and I'm going to show here a very example of what we call blue-green deployments. And it's also very complex to do blue-green deployments on OpenShift. So the purpose of blue-green, as I said, is to make an update while still allowing access to the application. So let me see if I can show this correctly. So I'm going to open the EEP application here. It's not going to turn green. I'm sorry, the application is not going to turn green. Oh, can it turn green? I think I'll be able to make it turn green. So I'm going to do this thing, right? You're going to have to follow me on this one. Okay, I'm going to leave this here. I'm going to leave this window here, right? It's a lot of things I'm going to have to do because, again, we're doing demos live, right? And I'm brave enough to do this demo live. So I have this application here, which is my to-do list. This application here, it uses a database. So it's using a Mongo database, right? If they tell you that container is only for stateless environments, that's a lie. That's a Mongo database, as good or bad that is. Yeah. So I'm going to see how this blue-green thing works, right? So I have the blue here, and I'm going to use a Chrome extension that I just discovered called refresh, right? So I'm going to make this thing refresh every second, right? So yeah, awesome. So it's refreshing every second, and hopefully I'll be able to show an update on the application without downtime, and then you see it going from blue to green, okay? Let me access OpenShift. As you can see, our UI is responsive, so as I change it adapts, which is very good. So you can see the UI also on your mobile phones. Going to access this build, EAP application. This is the builds that I had, configuration for my build. This is the source code. All right. So I'm going to open the source code, and I'm going to change the source code right here, right now. I'm not going to do the webhook what should I do? I think I'm going to do the webhook thing. Okay. Oh, this demo is becoming longer. Do we have time? I think we have time, right? We have time. Right? So let me go back on my deployment configuration, deployments, and then, oh, this is too small. I can't see what's going on.
Let's show them the fast version. We've got a bunch of stuff to show them. Because we'll show them things like, what happens if hosts die, and we just come back.
Okay. All right. So I want to enable the webhook because that thing is cool. So I'm on the build. It's a build trigger. So I want my application to be built whenever there's a code change. So this is the configuration for my build. This is my GitHub webhook. So there it is. I'm going to come here to my project, change the settings of the project, configure the webhook, right? Webhooks. Okay, webhook, thank you very much. My password, GitHub123. Okay, let's add this thing. I'm adding, it's all live. It's all live, like I'm very brave. It's all live. Okay, so I add a webhook. And a webhook essentially is a way of having your source code manager tell someone that the code has changed, right? So I'm going to go back here to my code. Find the correct tag so I don't make a bad demo. This one, yay. Okay, get in there. And index.html. And let's do one thing here. I'm going to change this, right? So as you can see, I have here a background color, light blue, right? So I'm going to change this guy to light green. Right? And I'm a very good developer. So good developers, they comment their changes. Yeah. Very bad developers commit the changes on the master branch. Okay. So that's what I did. So luckily my webhook worked. So let's see if it actually did. Builds. Okay, there is a build that was running. Awesome. Whew. So that worked, So we have a build that's running. So while this build is running, I'm going to show you a bit of the OpenShift architecture with the green, with this screen here on the right. Let's see how that goes. It's not going to work. I think let's talk a little bit about where OpenShift comes from. We should talk a little bit about where it comes from. That it uses Docker and Kubernetes while it does the build. The technologies we rely, where Kubernetes came from.
Yeah. So why don't you jump to one of those stacky slides. Yeah, go to that one. Sure. So the thing to think about. So what you guys saw was I've given the developers a lot of freedom. You can go build in whatever language you want to. Given you a bunch of tools to be able to say push these into the platform however you sort of want to. And then there's a bunch of things from an operations perspective or DevOps perspective that are going to let you build it, deploy it, control it, manage it, and so forth. But then you sort of go, well, okay, what really happened? What was some of the magic that went on there? And it really builds on this stack that, if you think about it, all these new technologies that we're hearing about, whether it's Docker, whether it's Kubernetes, whether it's Mesos, whether it's whatever it might be, are all built on Linux. And so the foundational thing that you're building off of this here tends to be, whoops, that'll come back in a second, is you're going to build off a sort of stable, well-known enterprise Linux. So everything that you're seeing here, all the platform is running on top of either RHEL, so full-blown RHEL 7, or, as people were asking some of the questions about security, if I'm moving towards a more container-centric world, do I need such a large piece of underlying Linux code? We've adapted to that. We've made essentially what's called RHEL Atomic. So think about it as a very small footprint version of RHEL that is specifically built for containers. It's built on how containers get updated. It's got a very small footprint, only the things that you need to run containers. On top of that, you say, okay, great. So I've got a secure host. I've got a host that has all the tools I need to run containers. How do I take care of multiple hosts? How do I make sure that I can network them, that I can make sure I can find them, do service discovery, I can associate them with storage and so forth? And that's where we leverage a technology that's called Kubernetes. And Kubernetes, at its core, is a technology that was open sourced about 1.5 years ago. It comes from about 10 years of Google running containers in their production environment. So anybody who's ever used Gmail or Search or Maps or anything like that, you're familiar with this technology. You don't know it, but you're familiar with it. It used to be called Borg, still called Borg. They took that, they started saying, hey, you know what? We're seeing more and more companies that are trying to do these new innovative things. We should open source some of this technology, make it easier for them rather than reinventing the wheel. We made a huge investment around this about 2.5 years ago. We're about the number 2 or number 3 contributor on any given month. But what Kubernetes does as a core technology is it schedules containers, it orchestrates which hosts they end up going on, so things you don't have to think about. It makes sure that however many instances you want running is always running. So if for some reason you lose a host and it drops down to 2 or 3 and it's supposed to be 8, it's going to make sure it finds those other hosts that will run it. It's going to make sure that if for some reason something went wrong and it gave you too many because you scaled way up and traffic slowed down, it's going to scale that back down so you're efficient. So the core technologies that are built on here, RHEL, giving you a rock-solid foundation from an OS perspective, Docker, that standard container format, which is evolving into the Open Container Initiative, Open Container, and then Kubernetes as that sort of scalable infrastructure for being able to manage, scale, and orchestrate containers. And then what OpenShift ultimately does is OpenShift says, that's great, but there are a number of things that people want above and beyond that from a packaging perspective and so forth. So you see us integrating container or registry technology. You see us integrating storage technology to be able to do persistence. You see us doing things around the user interface, around how we integrate with other open technologies like Jenkins and so forth. And so you take these core technologies, you wrap the things that you need from an enterprise perspective, from availability and security perspective, and the other enterprise applications. And what you ultimately get is this experience for your developers. Highly available, highly automated, very, very simple to use.
And you saw that things quite didn't work perfectly here on my Bluegreen Deployments. So I was thinking, like, what did I miss? So there are a few things that I missed here in my demo, which will help me explain how awesome it is to have a resilient platform, right? I'm going to use this application for, I think I'm out of resources, so that's why it's not scaling back to 12, which is fine. So it's trying to create more containers. My machine does not have necessary resources to scale up. That's fine. So let me show you like a deployment configuration. So there's one very interesting thing that the OpenShift is telling me. Like, this node has containers without health checks, which ensure your application is running correctly. Right? So health checks, let me just go to the health checks web page, which is what I missed. And then I'm finishing this, and then we're going to wrap up, right? Now, as you saw when my application went up, it stayed unavailable for a while. And then that's for Java applications, when your Java process starts, that does not mean that your application is available right there, right? You have to wait for the application server to start up. Sometimes you have a cache warm-out, lots of other things, right? So one of the things that you can add to any of your applications is what we call a readiness probe, which can be as simple as this, which is just an HTTP check. So it's going to call an HTTP, and if it gets any answer 200 on 200 or 300 series, it's going to say, okay, that container is able to receive requests. That means I can add that container to my router, and that means that now we can start sending requests to that container. This is readiness probe. Now there's a very other important thing, which is liveness probe. So one thing is preparing your container to run the first time. But the other is like, how do I know that my container is running? And not only that my process is running, is that my container is running on a healthy state. So you can also add a liveness probe, which can be, again, any REST endpoints or any endpoint that you query on your file, or any really a bash script that you call on your container. So your container could tell OpenShift, they say like, yes, I am healthy. Please don't kill me. Because if anything happens, if OpenShift finds that your container is not healthy for any reason, then OpenShift is going to kill you. And I think one very last demo, and then we're about to be done. So,
you want to do that, or you want to ask for?
Oh yeah, that's a good question. Oh my God, I'm sorry.
Any questions? We sort of got to rambling and showing off a bunch of stuff. Any questions that you have first, and then if there's a last piece of the demo, we can always do that from a timing perspective. Questions about containers, questions about platforms as a service.
Any questions? All right, you're just wowing them. They're just in awe.
Yeah.
They have nothing to say.
Awesome.
So keep going.
Cool. So yeah, one last thing, because I like to to try the complex things. And this is just to show resilience of the platform. I have the exact same console here on both ends, right? I'm going to scale this back to, I'm going to do this on this other, right? So on this other application. Is this telling me I should stop? Okay. So maybe, right? So we have a very nice thing, which is the ability to see a terminal inside a container. So this terminal that you see here, that I know it's small, it's a terminal running inside this container that's on the right, right? So a little bit of my very, very awesome Unix skills here. PS, that's a very complex Unix skills command. It's just, PS is telling me what are the processes that I have running. Forgive my poor screen. And now it tells me that I have this process here called node server.js. So let me try killing this server to see what happens, this process to see what's happened. So like, I'm going to kill the 24, and if it's not dead, I'm going to kill 1. Okay. So as you can see here, what happened is that, and that was very fast, I can do it again.
Watch the thing to the right.
Watch the thing, watch the circle here, right? So this is the resiliency of the platform. Let's say someone kicks the power table, or there's a network failure, or something very bad happened to your container. Let's say unexpected failure. And this shows the resiliency of the platform. So I'm going to kill the process again, 33 now, right? So this is what happened. OpenShift, it works in a declarative manner. So when it sees that applications are not running in the state they should be, it will always try to restore the application that state. So what's doing here is that, it's identify that container was crashing. And then if I crash this container for the 3rd time, OpenShift is going to ask, so this container has been crashing too much. Do you want me to open a debug window so the container doesn't crash and you can take a look at what's going on, right? So, and this is what will happen here. But this is my lesson that I wanted to show you here. And I think I'm just going to do C cluster down, right? To shut down my cluster because it's I don't need it anymore. I already did the development I had to do. And that's what we had to show you and to present you. Thank you.
Thank you, guys.
All right. Thanks, Brian. Thanks, Diogenes. Just before they go, any last questions? All right. Then that's great. Then that's great stuff. I don't think one person left the room, and that's a good sign. I'm no expert on this, but that's a good thing. So first, I want to congratulate everybody for getting to happy hour. That's just, it took a lot of perseverance. I know, hot, cold, whatever. So thank you very much for today. We can't show our appreciation more than just thanking you and being here for your questions. There's happy hour right now. One thing, remind you, we have this really fun drone that wants to be won. And so you have to fill out your surveys and make sure you hand your survey in. Okay, you can't win. It's like the lottery. And beyond that, please make sure on the surveys we really want to hear the negative and the positive, right? We want to make sure that we get better. So if you feel like, there's a couple of things I didn't like, but I'm not going to mention them, mention them. Why not? It's only going to make us better as we kind of move forward. We're going to do these regularly. So hopefully we'll see you all again soon. Hopefully today was very useful. Have a great day. Enjoy the happy hour, and look forward to seeing you all again soon.